So let's determine the interval or intervals on which f of x equals 3x minus ln of 2x is concave up. Well, the values where it is concave up, that original function, are the values that make the second derivative positive. So let's figure out what the second derivative is. If our function is 3x minus ln of 2x, then our first derivative is going to be 3 minus, now the derivative of ln of 2x, that's 1 over 2x, times, because of the chain rule, 2. So cleaning that up, that's going to be 3 minus 1 over x. Now let's rewrite that as 3 minus x to the negative 1 power so that we can take our second derivative. Our second derivative is going to be, well, the derivative of 3 is 0. The derivative of negative x to the negative first power is x to the negative second power. So that's going to be 1 over x squared. Now, we're interested in the values of x that are in the domain of our original function and that make the second derivative positive. What is the domain of this original function f? Well, the natural log can only take positive inputs. So the domain of this original function is x's that are strictly greater than 0. So we want x's that are strictly greater than 0 that make our second derivative positive. Well, our second derivative is going to be positive for all of those values of x, right? Because we have an x squared here and we have a 1, so it's always going to be positive. So that means that our second derivative is going to be positive for x's that are greater than 0. So we would choose option D.